Hello, students. Today we are going to explore the topic of water treatment. Water treatment is the process of removing contaminants and impurities from water to make it safe for use. There are two primary approaches to water treatment. One is internal treatment, another one is external treatment. We will look into the details of what is external treatment involves and the entire process involved in the external treatment process. Let's see one by one. I hope you all know that the hot water directly taken into the boiler because it makes so many troubles. External treatment is one among the process which is used to remove all the harmless causing agent before it is taken into the boiler. There are two process involved in external treatment process. One is ion exchange process and then another one is geolite process. Let's see the geolite process first. So geolite is nothing but a hydrated sodium aluminosilicate, and it possesses a formula of Na2O, Al2O3, XSiO2 and OH2O. So X and Y stands for number of silica and water molecule present in the geolite compound. But the problem in natural geolite is it possesses a non-porous structure, so it cannot be used to remove the harness causing agent present in the water. That's why we go for the synthetic geolite. So it's simply represented as sodium geolite. So the sodium which is present in the geolite compound is loosely attached to the geolite molecule so that it can readily replace the calcium and magnesium ions present in the water. So here, uh, the cylinder is used to remove the harness causing agent present in the water, which containing a geolite bed, which is attached with sodium geolite bed. So what happens is when hot water is passed into the cylinder, the sodium geolite bed um, containing sodium ions have a capacity to replace the calcium and magnesium ion, that is harness causing agent present in the water. So the sodium will react with the calcium and magnesium molecules present, magnesium ions present in the water molecules, and readily replace that ions from the water. So what happens is the calcium and magnesium ions, that is harness causing elements, will deposit at the bed itself, and the water which is coming out of the cylinder is completely free from all the harness causing agent, that is calcium and magnesium ions. But it contains so many sodium salts, okay, like sodium bicarbonate, sodium sulfate, sodium chloride, like that. So many sodium salts may present in the water which is coming out of the boilers. Okay, so if you're continuously using the sodium geolite bed, then automatically one particular time the geolite bed get exhausted, so that we need to replace the geolite bed again by passing the 10% solution of sodium chloride. So what happens is that sodium chloride will react with the uh, calcium and magnesium deposited geolite bed, and again that will replace the calcium and magnesium chloride, remove the calcium and magnesium chloride ions, and again sodium geolite bed will be regenerated. Okay, so the main advantage of geolite process is here all the harness causing agents are removed, so we get the water up, the harness will be reduced up to 1 to 2 ppm. And then this method is very cheap and economically, it is beneficiable one, so that we can use it again and again. But the disadvantages process involved in the process is there are too many, there are so many disadvantages present in the geolite process. That is, we cannot treat the turbid water, and also we cannot treat the acidic water because both, if the turbid water is present, then automatically it will block the pores present in the geolite bed, and the acidic water also will damage the geolite bed. And also, we cannot treat the brackish water because it already contains sodium ions, and the geolite bit also contains sodium ions. So we can so there is no use of removing the sodium ions present in the brackish water, because again the outcoming water also will contain sodium ions, and water which containing iron and manganese also cannot be treated because it will form a strong complex with the zeolite process, so we cannot regenerate the bed again. So for overcoming these process, sorry, for overcoming this, to overcome all these disadvantages, we are using another external treatment process, that is ion exchange process. So ion exchange process used to remove not only the calcium and magnesium ion, that is harness causing agent, but it also remove all the unwanted cations and anions present in the water. Okay, that is why the water which is produced by the ion exchange process is said to be a demineralized water. Okay, so in the demineralization process, we are using ion exchanging resin for replacing cations and anions present in the water. So ion exchanging resin is nothing but a long chain cross-linked organic polymer, so which possesses a microporous structure so that it can readily replace all the cations and anions present in the water. Okay, so generally cation exchanging resin is said to be a cation exchanger, and anion exchanging resin is said to be an anion exchanger. And cation exchanger is nothing but the resin which containing acidic functional group, and it readily exchange the H plus ion, and it is simply represented as RH2. So some examples of cation exchanger is sulfonated coals and sulfonated polystyrene. And then anion exchanger is nothing but it is a resin which containing a basic functional group like NH2 and OH, and it readily exchange the anions, that is negative ions present in the water, and it is simply represented as RH2. So generally cross-linked quaternary ammonium salts and urea formaldehyde resins is used as an anion exchanger. So this is a experimental setup which is used to remove the all the cations and anions present in the water. So this is a setup which is used in the ion exchanging process. So what happens is here the water, that is the water containing all the cations and anions is passed into the cation exchanger column first. So here cation exchanger is fixed in the column. So what happens is this cation exchanger will replace the all the cations present in the water. So next, the cation free water is next passed into the anion exchanger column, which containing anion exchanger. So what happens is that anion exchanger will replace the all the anions present in the water. So the water which is coming out of the anion exchanger is completely free from all the cations and anions, and that is why it is called as deionized or demineralized water. So on particular time, similar on particular time, definitely the cation exchanger and anion exchanger uh, will um, will completely blocked by the cations and anions, so that we need to regenerate the cation and anion exchanger by passing dilute HCl and dilute NaOH. So let's see the reaction. So when hot water is passed into the cation exchanger, so it's simply represented RH2. So what happens is that cation exchanger will replace all the positive ions present in the water. That is a Ca, magnesium, and sodium. All the positive ions will deposit in the cation exchanger column itself, and the water which is coming out only contain a negative ions. So that cation-free water is passed into the anion exchanger, uh, which containing anion exchanger. So what happens is, so this anion exchanger will have a capacity to replace the negative ions present in the water, that is chlorine, sulfide. So all are removed, all are deposited in the anion exchanger itself, and the water which is coming out of the anion exchanger is completely free from all the cations and anions. So the cation exchanger and anion exchanger is replaced or regenerated by adding HCl and sodium hydroxide. Once the cation exchanging resin is exhausted, then automatically it is regenerated by adding HCl solutions. So again, when we are adding HCl, then again cation exchanger will be regenerated. Similarly, the anion exchanging resin is regenerated by adding sodium hydroxide. So the main advantage of this process here, we can even be using acidic and alkaline water Um, Even acidic and alkaline water also can be treated by this process. And water will have the water which we obtain will possess only a very low hardness, almost 1 to 2 ppm hardness only present in the treated water. So here also we have some disadvantages. The advantage is the equipment is costly and this is more expensive. Chemicals are needed to treat the water. And here also we cannot treat the turbid water, and again iron and manganese water cannot be treated because turbidity will block the pore present in ion exchanging resins, so the output automatically get reduced. Similarly, the iron and manganese compound water can uh, can also be not treated by this process because it forms a strong complex with the resins, so we cannot regenerate the resins again. So let's see the it conclude these two process. So geolite process and demineralization process. So in the geolite process, we can exchange only cation, that is harness clouding agents only removed, that is calcium and magnesium ions only removed. But in the demineralization process, we remove both the cations as well as the anions. And here acidic water cannot be treated by this process, but in the demineralization process, we can treat the acidic water. And the water which containing large amount of dissolved salts leads to priming, foaming, casting improvements in boilers. Okay, because it contains so many, the treated water containing so many dissolved solids. Okay, large amount of dissolved solids. But here, the treated water does not contain any dissolved salt, so there is no possibility for the priming and foaming in the boilers. So that's all about the external treatment process. Thank you.